End devices, 5G enabled wireless microphones and the IEM systems as well as software defined radio SDR prototypes for the live audio production use case. SMPTE Society of Motion Picture and Television Engineers, uh, 5 2110 5G gateway and 5G modems for the multiple camera wireless studio use case and a free viewpoint FVV systems for the live immersive media production use case UC3 radio access network, dynamic spectrum access techniques, and virtualized RAN to deliver true multi-vendor disaggregated and RAN intelligent control RIC services for UCI. RAN equipment working on the 3.7 to 3.8 gigahertz band for UC2 and mmWave equipment for UC3 core network for all use cases. A complete and flexible 5G core is used, which includes additional new network functions, network slicing solutions based on SDN as well as edge computing processing, orchestration, orchestration and management mechanism, media orchestration and control implemented via operational control gateway and operational uh, control adaptation layer implemented through media gateway. These all are under the goal is to go beyond existing capabilities and technologies. Integrating audio PMSC applications into 5G will facilitate new ways of AV production. The use case architecture consists of the following components we have seen. So next one, indent based end-to-end E2E network slice deployment for verticals. A vertical service layer on top of the 3GPP slice management system as proposed in 2 to 28 and 2 to 29 provides the management logic to coordinate the provisioning and the actions controlling the life cycle of vertical services deployed in 5G networks, starting from verticals intents expressed through vertical service blueprints and descriptors. This layer identifies the characteristics of the end-to-end network slices required to meet the application requirements, selecting the suitable slice templates. Such templates are then used by the slice management entities to drive the provisioning of the network slice subnets related to the access core and transport networks together with the virtual functions or applications associated to the vertical service on the basis of the slide and service profiles and figure 2.15 next figure this one. Further, the details on the approach to managing network slices for concurrent vertical services, translating the service requirements, and arbitrating the slice resources across multiple services are described in section 5.2.1. Okay, from verticals intended to end-to-end network slice deployment. Vertical service layer VSP, vertical service layer contain VSP and VSD. VSP vertical service blueprint. It is the vertical service blueprint is the high level and vertical oriented service description. VSD vertical service descriptor intended for service installation. Then NEFO, ETSI character, NSD, PNFT. network service descriptor NSD, VNF CNF descriptor, SDN controller net connect service. These all are connected to actually from this vertical service layer connected to signal going to network slice and slice subnets management. From this network slice and slice subnets management reaching to this NEFO and SDN controller. Yes, this network slice and slice subnets management contains what is having NSC, use case, GST, NEST, requirements, network slice instance preparation, GSMA, NG 116, generic network slice temperature, version 4.0. That is NSC connected to use case connected to requirements connected to NEST and GST connected to back the NEST connected to network slice instance preparation. So from here GSMA NG 116 generic network slice template version 4.0 case flow. So information object class network slice data type service profile information object class network slice subnet data type slice profile information object class manage function NSS MFS access network core network transport network vertical arc open model class preliminary network service NS include enough open model class preliminary VNF. NetApp principles and implementation aspects. A network application is a software piece that interacts with the control plane of a mobile network by consuming exposed APIs, northbound APIs of 5G core and or MEC APIs in standardized and trusted way. That is for a 5G network, a NetApp should be CABIF compliant 22226 to compose services for the vertical industries. A NetApp provides services to vertical applications either as an integrated part of the vertical applications or by exposing APIs which are referred to as a business APIs. The NetApp ecosystem is more than the introduction of a new vertical applications that have 5G interaction capabilities. It refers to the request for a separate middleware layer that will simplify the implementation and deployment of vertical systems at a large scale, considering also the adaptation needed for non-public 5G network 5G NPN deployments. This is the same request that triggered the development of vertical application enables VAG by 3GPP SAC. Considering the level of interaction and trust, the NetApps are classified to third-party NetApp. NetApp that resides at a trusted third-party domain. A third-party NetApp consumes northbound APIs and also supports the trust mechanisms and security policies defined by the network for the verticals. Operator NetApp. NetApps that reside at the operator domain, considering mainly NPN deployments and potentiality. It can have further access to 5G network capabilities beyond those provided through the northbound APIs. Vertical, that is example, vertical space functionality at the OSS for slice management and are available in the third-party NetApp. Considering the way that the service provided to verticals, the NetApps are classified to standalone NetApp that provides complete services to one or more vertical industries either directly or through its integration to a vertical application. A NetApp that is integrated into a vertical application enhances the functionality of the application by adding network management and monitoring capability exposed by the 5G network. Next one is the standalone NetApp that operates a wrapper of northbound APIs to expose services through business APIs. It is an auxiliary non-standalone software PC in the sense that it becomes functional when business APIs are consumed by an app. A non-standard NetApp allows vertical applications to be developed, upgraded, and take advantage of the 5G exposure capabilities without changing integral parts of their software. That is only by consuming business APIs. Vertical app, NetApp's SDK, 5G network, APIs, 5G, third party standalone NetApp presentation. Vertical app, business APIs, NetApp, 5G network. Third party non-standard. This is standalone. This is non-standalone NetApp representation. From architecture perspective, NetApp is a part of the vertical application server VAS as defined by 2.2.27. Okay, then in this figure, adding the NetApp concept in the service provisioning chain. Vertical app client UE 5G network slice access network service data flow 1 service data flow 2 here data connection UPF data interface vertical app server. Here UE vertical app client 5G network slice access network service data flow 1 service data flow 2 data connection NEF northbound APIs control interface UPF data interface AF NetApp vertical app server data interface control interface component of vertical app that communicates with the 5G network via the control interface. Component of vertical app that communicates with the client via the data interface. Adding the NetApp concept in the service provisioning chain. And then here as a northbound API is consider the NF seal and the other APIs emerge through 3GPP release 70 example FF VAE trusted security aspects of consuming those APIs are addressed by CAPIF core function. NetApp's consuming 5G northbound and CAPIF APIs. Trusted third-party domain. NetApp connected here application provider and CAPIF core function. App provider having seal FIF NEFC. This is the 5G APIs. This is a CAP IF APIs. So operator domains. This is the NetApp consuming 5G northbound and CAP IF APIs. The following implementation remarks can be made in relation to the NetApp concept. The NetApp can be virtualized, containerized to reside at any trusted third-party domain or in the operator domain. Container-based NetApps are considered in 2.2 to 37 to 41. Any NetApp includes a client to consume 5G APIs. The basic NetApp exposure REST APIs, business APIs as well. The NetApps are instantiated during the development time of a VAS. The NetApp developer creates the record APIs. Other implementation options might use API framework. NetApp will essentially be a small REST API app. Here, this is the NetApps implementation